Hello, good afternoon. So, my name is Mathilde. I'm French, but I've been working for Varysian for 5 years now, and I specialize in the consultancy aspects of the activities of Varysian. So today, I'm here to talk about historical data rescue, which I think most of you already know. But I'm going to introduce what we do with AI, and so we call it the AI revolution. So hopefully, at the end of this discussion, I want you to ask questions and react. So please listen carefully because I will ask questions. All right. So our agenda today. So I'm going to touch upon historical climate data rescue again for those who don't know already, but I think most of you already know. Then I will explain what we intend to do at Varysian and how we plan on editing a new updated roadmap. And then I will introduce the AI revolution with a little video. So the urgency of there, I think we all know, we've been aware since the year 2000 or so, that the more data we have, the better predictions we can make. And for the better part of the world, in the northern hemisphere, this has been done. But for some parts, and Africa is one of the parts where some of the data is missing, and the Pacific as well. There are 2 spots in the world that are really missing. And so we need to focus our efforts to make sure we save this data before it disappears or it degrades. So there is an urgency. As I said, everybody knows that, so I will pass. I want to go through the cycle of what data rescue means and how it goes. So first of all, we need to identify the data sources, if they're still there. We had an example in Sierra Leone where the data was actually destroyed during the civil war, so normal data, it will not be saved. And then we need to make sure we have the agreement to have access to this data. Sometimes it's scattered between different agencies, or it's around the country, far away from each other, so it's hard to have like some centralized archive understanding. All right, then we need to audit it, so you can follow it. And then we need to capture it, so which means today we don't have very much alternative than to take a paper, scan it, and use the scan. But we haven't found another way. The AI revolution comes next. So then we need to digitalize it. So we scan it, and then we need to key it into a system, so it comes from physical to numerical or digital. We need to quality check what's there to make sure it's in line with the records. And then we need to anonymize the records, make sure we have the metadata available, which sometimes is lacking. And then we can go and publish the data. Either we publish the data in the country, or if it's possible, we publish it, it's global data, and we share it to the global networks of, it used to be WMO, but now it's under the Copernicus EU website. Right, so this is where AI is happening, right there, and this is coming. So, what has been done? 1978, this is the first time we really thought about we should save the data, we should not let this data die. And when we speak about historical data, it's usually from 1850 to 1950. So the old data, as we call it, it's usually manuscript. Sometimes it's beautifully done, sometimes it's done in a way that we can't read it anymore. So it makes it difficult for a human even to read it. So imagine a machine. So first I want to do data rescue, which has been actually conducted. In 2001, we look behind and we look at what's been done. And for 20 years, there were some efforts to digitalisation, which is scanning only. And if we look at the report from WMO, who was in charge of that, they said that they spent about 36 million to do that. And they put it on microfiche. I'm sorry, some people know the story, but it's an interesting story. They put it on microfiche because at the time, they thought it was the best way to preserve the data, because it's polyester, so it's supposed to last 500 years. However, they gave it to ACMAD, which we had a presentation this morning, and because of it's a delicate film, it's very tiny little images like this, and they got degraded to a point that they had holes in it, and they were not readable anymore. Disaster. And so we thought, because 20 years later, suddenly, the Belgian Services Institute, Royal Institute, who actually did that project in Africa, said, oh, but we have the copies, you know. So, good, everybody got relieved. And they're like, okay, sure, if you got the copies, then we can work on them. And they are right now sitting somewhere in Ireland, all these coffee sheets for 20 years of work. And then around that time, we realized that yes, historical data is as important as nowcasting data. 30 years, 50 years of data is not enough. If we can have 100 years, we will have better predictions, which was good that it happens in 2001. So where do we stand now in 2024? Where do we move? We've been looking into that for the last year or so. And I spoke to many European agencies, I spoke to some African countries and other countries, spoke with NOAA, the EU, the WMO, you name it. And we realized that the data was not really coordinated, like the management of the data wasn't coordinated. In each country, few people had access to the information of what actually happened in that country. And for most of the country, there was some deteriorating data. So the archives are actually molding in storage rooms, inaccessible, they are being destroyed. So we're losing the information just by wasting time. So I went on the IDEA portal, which is being migrated now, and I found that information. I was like, oh, it looks like 20 countries. It's self-reported, so you have to go yourself as a country and you have to report what you've been doing under the WMO. And it seems that 20 countries do have had their program. So it's good. Out of 54, it's not so bad. And we have, I don't want to emphasize that because we're in South Africa, but we have 124 years of data in South Africa, which is the longest chain of daily and sub-daily data in all the continents of Africa. So well done. Okay. So last year we started to send a survey, and some of you answered. Thank you very much. Actually, 100 people answered. And I just wanted to compare what we have as information laying there with the WMO and other actors, and what does Varysian gets to know when we go for grassroots information. And then we got different answers. 25 countries had their programs, 6 did not at all. And 23, I don't know yet, because we don't have information, and hopefully you will answer. So we're like, okay, discrepancies, sorry for South Africa, it's blank, I don't know what happened there. Yeah, but it's there, it's blue. And we were like, we need an up-to-date roadmap, because we don't know where we're going, we don't know where the data is lying. In each country, it's unclear where the data sometimes is, what's been done, what's not been done, and we're talking about millions of sheets. So it's like, even for a small country, in Uzbekistan, there is right now a mission being done for there. They had 17 million pages to be scanned. So, and then when I talk to different countries, they're like, yeah, sure, it's going to take 20 years. I'm like, 20 years? Okay. All right, so we are on this inventory, sorry. And then the first thing we're doing is we asked the NMHS, you understand what you need, what are your limitations? I'm going to give you some insights after this. And we will also go for the EU archives, because most of the European countries who were in Africa and left Africa had left with a lot of data. So sometimes, interestingly, there is a gap, and the gap is actually sitting somewhere in a country in Europe. So, and it's hopefully because of the policies we have in Europe, it's open, so we can have access to this data. It's given to us, and there is no resistance. I called FBT France, and they said, sure, have the data. I called the German DWD, they said, please, have the data. So at least it's easy to retrieve. And then we're going to compare, and that's a big thing for geeks. They have to go around all the publicly available data that's right there at the moment and compare in different databases where we stand. And then after all of that, we will have an up-to-date inventory. So that's the survey I mentioned, 100 respondents, 27 countries that fully completed our questionnaires, some fully, partially, and some are still missing. We will call them. All right, and from the results of that survey, we already have some very clear identified obstacles to data rescue. And the first one is lack of funding for 100% of respondents, and also lack of qualified personnel. So that is something we will be able to probably facilitate once we have a proper roadmap that's up to date. We can go and look for some funding. So that's the idea. And then I asked specifically the question, we have some proprietary restrictions. For some reason, nobody answered. I was like, that's not possible. And then I asked another question, because I knew already. And I said specifically, do you have, is your current national legislation supporting public data access? And it was a tie. So I know for some countries, it's a big problem, to be honest. All right. So if you remember the cycle that I showed you before, I asked the countries where they were standing on the cycle. So I understand the maturity of the cycles for each country. And so you can see for yourself, but we have some partial inventory of paper archives, which is the very first step to do. You need to know what you're dealing with physically. And then you have some partial digitalization, which is good, but key is always done with the humans. Humans take forever, there are some discrepancies. Usually you need 4 people to get to a 100% accuracy. So 4 pass, magic. And some partial metadata collection is they are the 3 biggest ones. So the idea for me is to understand what country is standing where and have some clusters of countries that can collaborate together because they are on the same level of maturity, they face the same problems. And so we can go as cluster of countries and ask for some support. So again, financial support is what is most needed. So this can be easily covered. I mean, it's not always easy, but money can be found. What's difficult is training people, is having access to technology, is having access to equipment, or a stable internet, or a stable electricity when you deal with this kind of data. Okay, the fun part. So how can AI, artificial intelligence, reinforce, support, speed up actually the data rescue process? So we are developing, there have been some development for years actually on AI applied to other type of industries, as you know, like the virtual reality, the robotics, many things have been applied. But when it comes to historical data, people are like, okay, but where is the money? So they don't see a direct economic value to it, so they didn't go there. But we do. So we are developing this. AI maybe for an understanding for some of you. So I remind you of the digital cycle and where it actually goes. And then I want to explain that in simple words, and then I make you a demo, so maybe it will be clearer for you. So for me, the added value of AI, and I guess it's not just for me, but for people who actually work with it, they see that you put in minimal resources and then it goes so fast and you got amazing results. That's in theory, in a beautiful world where everything works. But that's the idea. And so you go with automation. So it means instead of having, you have repetitive tasks, we all have repetitive tasks to do, but the machine can do it much faster. If you taught the machine how to do it, it will do it in a good way. What AI does on top of that is it's learning of its own mistakes. So it adjusts like a human would do, but it's a human training the machine. And so data, in our case, we have data recognition and extraction, meaning you put in front of the machine, it's a little bit artificial to say that, but you put it in front of the machine reads, it can read the text, or other source of data, it can read numbers, it can guess things, it can also extract the tables, the text, all of that in seconds. So when a human needs like 3 days to read a table and to put a key into the document and make mistakes while doing it, the machine will do it in a few seconds. Okay. So I'm going to use some terms so that you're going to learn. It's called optical character recognition. That's what it does, because it's not one artificial intelligence, it's intelligence. Actually, it's many components that put together, working together, actually give you the results you want. So you have to train them. Oh, it's up here weird, but okay. So imagine it can recognize numbers, handwritten text in a very good way. It can also translate. So right away, you see something in German you don't understand, you say, I want it in English, you get distracted, and then a second later, it's translated for you. And then you have some document classification. This is more into details. You don't need that. You have, I'm sorry, it's hard to read. And then you have some quality assessments, because once it's put into a numerical way, you can have medium, you can have sums, and you can have all the calculations made, and then it can tell you, oops, I think there's a mistake there, it doesn't make sense. The data is not how it should be. So on top of that, a human can always check, but it's already pre-made, like watch out for this, watch out for this, watch out for this. This looks to me weird. And then the human can say, you're right, machine. Okay, so a little demo view. So you can see how it's actually done from paper to digital.
Who's going?
Let's try out Asher's Document Intelligence Studio with 1892 June historical data. We kick off the run, and this analysis will do their AI model, OCR processing and document detection. We'll get out a table as well as text. The table is very interesting because what's happening, you can already tell, is that it's missing a whole column. Column 2, 3 were merged into just one column, and then column 3 and 4 were merged into just the third column here. So row 2 is missing the number, 3 is missing the number, 5 is missing the number. So rows, check marks where it was able to pick up a dash and then a really long comma that was added there. Ended up being detected as a check mark. Columns that are triple merge, double merge happen. Row 13 is a good one on this data. Every time on this 243 right here at the end of this is actually the row column 4 on this row 13. So you have this column, this column, this column, this column all being merged into one. So that the table recognition, while it is somewhat decent, the column structure analysis is not there. Other than that, we have the text recognition at the bottom is really interesting. This paper has ripple, and this ripple was done either during the picture process or it's just as kind of artifact. But it was able to decode that word, ABGEESEN. I think there's an L underneath of the fold because of just this, the wording is the same on all the documents, but this is able to still, Azure is able to decode that word, which is super interesting as the capability. I think Azure's out of the box solution is interesting because it gives us a lot of keys to figure out the next pieces. But this is the solution that we have today to help with the data initiative. Thank you.
Okay, so that's a little demo. I don't know if you've got it. All right. It's done with a team in America, actually, who's working and developing it. And there was a German handwritten sheet, you know. And then you can see the results. What I love this geek guys, because he only emphasizes on the negative. But what we saw is that it uploaded the sheet, and in 2 seconds, we got most of the table rights. And of course, there are some discrepancies here and there. So this is what we used. That was given by German's web services. And then this is the table that extracted in like 3 seconds, maybe 2.5 seconds, with mistakes. We agree, because the model is not trained. I'm just showing you the model the raw model, let's say, before it's been trained. And so once we have that, it's extracted. We use Azure because you have several clouds right now that offer this text recognition. Google is doing it, AWS is doing it, Azure is doing it, and Azure for now is the one that has the free product readily available, let's say. But now we need to train a model. That's where the brain comes, and that's where the work is interesting. Anyway, you can extract it, and you got an Excel table right there. So even if we just stop at this, and it's open source, anyone can do it today, you could have access to this table, and you would just have to rework on that table instead of starting from scratch. Just an idea. And these are the few discrepancies that we could see. That can't see anything on that screen. But the missing numbers and then the human eye in 1 second knows like, oh, so this is wrong. This doesn't make sense. The machine doesn't know, so we have to train it. So it recognizes it. So how do we train the machine? We take all the columns, all the recycle, all the elements, and we teach the machine. This should not be a long number of series. It should be 2 to 3 to 6, whatever, how the format is. This person writes 4 like 9. So every time you see a 4 and 9, just be very careful, machine, make sure it's the right number. And this is what we do. So AI is not a final product, it's not something we find. AI is actually an intelligence you train as a human. You train the machine on how to learn. So in that example specifically, we saw the different challenges. The tables are not right, it doesn't recognize the table. The handwritten and cursive text has some issues because of the comma, it thinks it's a tick box, nothing to do there. So all of this can be arranged just training the models. So it takes time because the first time you take the page, you train a model. When the model is trained, you run it another time, and then you run it and you teach it like a kid until they can, from walking to crawling to walking to running. That's the same idea. The machine will do that. So, but you also see how much time we can save using trained AI models. And we are planning to do this. We have lots of data to play around with, and we intend to get much more. And once the program is finalized, the idea is to have a final product when you can upload your own data, and then you can extract almost perfectly what comes out of it. That's the idea of the final product, let's call it. But it's open source. Of course, for all of this to happen, we have first to have access to the historical data, make sure it's viable historical data, the readable data, and then we need to ensure a few things. So we need to make sure we can have access to it, which in some countries is tricky, for whatever reasons. But I think with time now we understand the importance of having access oneself to this data and maybe sharing it to the world. So we need to ensure open data access. The second one is, they're not against each other. They can very well be, you can have open data and you can monetize some of it. Because right now, today, the way it's saved the data, because it's so time consuming, so resource consuming, well, you say, okay, I'm going to just go for temperature and precipitation, and that's it. Because I'm not going to pay someone to do that like for the next 10 years. But with AI, you can actually extract all the information on the sheet and use it later on when you actually need it for some project or someone coming to you and say, I need that specific data, do you have it? Right? And be able to value it later on. And then we need to, and it's easy nowadays, but it took some years to be normal, but we need to work for the promotion and development of PTE. In that domain as well. So the public sector is not afraid to work with the private sector to develop and work on this climate data together. And then I think what's most important is to build the capacity in any case, because it will always need some human resources. The machine will never take the place of the human because it's actually, first of all, the human who trains the machine, and the machine needs the human to keep training it so it keeps being enhanced. That's it. Question.
Good question. Actually, this This is very nice what you're doing. But especially with the growth in machine learning, forecasting, and those kind of things. And many big companies like IBM use machine learning and some of it to forecast also. The limit is always available. So this could really help them in the future. What you've shown here is just basically quality control of machines. But for instance, if you have everything in the company, you could start doing spatial quality assessment, because if one sensor is off from another sensor, because those are the kind of things which you can then feed into the climate or in the climate change program. So I think this is extremely valuable in terms of the future for that. And I think there's ways that you, once you've done this, to take this beyond this, in terms of getting a data set that is both spatially and temporal consistent with everything else. And I think you should think about that in terms of the future, not only this part, but you can go beyond.
Thank you. I agree. It's just indeed the beginning, like the historical data is a tricky part, but we can develop it to nowadays we have sheets, or even like most recent sheets that are typed on the computer or were printed or on a typewriter. So easy to read from machine, like in seconds. But yeah, to your point, I agree that now many other
The other application, just building on that point, I think is building that into the reanalysis time cost data. That's one of the things that the value that would be in that already existing year 5 and coming up in year 6 time cost data to have a much more dense observation network of these traditionally data sparse areas. So another thing to think about, I think, is the reanalysis, because that's hugely valuable in this case.
anything negative or I usually done with it.
Yeah, thank you. It's very good work that was done. Now, on the Congress, let's say that we will present data that you will say that the data should be shared. And this software is going to work with those data that we share. With this software, every financial impact, or we create for the fund that we want to digitalize the data.
Very good. It depends how actually the model and the solution has been developed and who actually primarily financed it. If it's an international organization, it becomes a free open project. If it's a private organization, it has some proprietary rights to it, so it's difficult to answer. But we plan on having a solution that's open and freely usable. But for that, to reach that point, we need to have so much data. We need to test the model for a while before it's actually a functional model that can be up there. But we aiming at it.
Thank you very much for the presentation, especially in transforming data from the hard copy to the digitized format. And the table format was the challenge. And nowadays there are a lot of AI tools also online kind of open source that people are using to convert from Word picture to text format or digital. How are you ensuring that you look unique to that, and when would this be ready for use?
It's unique because what you have online, the open source you're using, I guess, if you're not paying, and I don't think they will be paying at the moment anyway, is limited in its capacity. I mean, what you saw is good, it's not good enough. I don't know, like, if you have a radiologist in the room, they will like, we want 99.9 accuracy. Okay, so this is not yet there. So the idea is to actually build with coding behind. So we have a nice little machine and we're going to make it a monster. And but for that, we need work, we need coding. So we need to rework on the code that's available and fine it, so it works for historical data. Because there are many things that are working, the table recognition, not so well. Some of the manuscript, not so well. And Google's working on it. It's working fine to some extent, but not to that extent. They are something very specific to climate, and to you know, the little glyphs, are very specific. So I don't know what your experience, and we can do later, but we plan on having, if everything goes according to plan, in a year time, the model will be available, the solutions will be ready. We need 1 year.
Okay, thank you for this statement. My question is, in the historical data, we found there is a lot of data gaps. Even the one you showed them, we have those data gaps. And usually in the manual scanning, we use these common methods to fill the gaps. Now, I want to know whether the machine can be trained to fill those gaps using the standard methods.
So I don't know if the machine can, I think a human can, a mathematician can. It's called linearization. So they try to analyze the overall, I'm not a mathematician, so, but for what I can, because I had the same thing, it's true they have some gaps during the same day, over the week, or even for years, you know, you have some gaps. So you need some sort of like linearization of the data. The machine won't be able to do that. We can train it, but we need a mathematician to sit with us and help us train it. So it's something that will come second, I think. Because we will focus on data sets that are linear for now, because you know we have so much anyway to deal with. So we will focus on the good data sets, and when we have too much holes, for instance, the country has too much hole and we still need to process the data, then we will look into that. But for me, it's a secondary issue that will come up, but it will be treated after the main model is developed.
But I do think for sure the machine can do it. We've done that.
What's the level of accuracy?
If you have short gaps.
Sure, yeah.
Yes, you have short gaps.
Yeah.
This way.
Very good.
Mhm.
Thank you.
Yeah.
Thank you so much for your presentation and your report. So I've seen for a point that some sub-Saharan Africa countries are in blue, but it is under their program, we say. I guess it's about the CLIMSA program.
Yeah.
Yes. And we are supposed to, because I'm reading the email from Matches, and they are going to send us data rescue equipment. Yes, that I'm wondering if CLIMSA program was discussed with you about applying this new technology on this CLIMSA program on data rescue, because there is no need to do the same thing, because Madagascar has already its data for fish at night. Yeah. Now I'm ready to have a look what is exactly this new program with the CLIMSA about data rescue. Yeah.
Okay,
Yeah.
thank you. Yeah, Madagascar is very specific actually, and a lot of your historical data has been sitting with Météo France.
Yes.
I actually had a lot of information from your country. Yeah, okay. But CLIMSA and other initiatives are very interesting. We are coordinating with them at the higher level, so they know that we are doing this. So everybody knows actually we're doing this. We're in contact with their community, and it's like the scientific community of there, and we will be informed. When you say equipment, do you mean for scanning?
I just asked the Matthias.
Okay. Okay. But we can discuss later if you want. Yeah. Okay, thank you.
So I just want to ask, because now you talk about all the organization itself, in terms of the collection, fill up the gaps, together with extrapolation and the interpolation. Because sometimes it is a combination of those that can assist, but sometimes there can be deviations and the norm which is what we are holding this. when you say that it's you are going to are you also considering the blend of the in-situ observation into each of models?
We're going into too much detail there, because that's a good question. This is not my topic. I really like the orchestra chef, the one who is making all the entries today. And I cannot specifically answer your question, except for linearization, that we look into this. I know we can distort the model, I understand about that. And we haven't found the mathematician yet to work on this, because right now we're focusing on the AI development. And then once we see, okay, there are too many gaps, we need to ask for an expert. It will come second, I think. It's a very good point, but you're too far advanced already in the plan. Yeah.
Then just a question for you. I know we have a number of countries in Africa that would like to carry out data rescue. A number of proposals that we are doing currently is to support some of these countries to be able to carry out this. I know close to 5, 6, 7 countries that are intending to do this coming soon. So I want to ask you, how reliable is this tool? Have you tried it already? The data that you have already rescued, someone has looked at either there is no discrepancy, and then if this is the case, I could be able to link this tool to some of the projects that we have. By the time to do rescue, then we will be able to speed up the process of trying to digitize this data for these countries. But I just want to be sure that it's been a good job. We tried it and it's okay.
Thank you for your comment. Yeah, so we are, luckily, some of the data has already been saved for some countries. So it's actually been done the traditional way, digitalized by human, check 4 times, meteorologist checking quality control, all of this has been done. So for some countries, what we do, how we develop the model to make sure it's the same quality level, we run the model. And we say, so how did you do? And then we check with the final results that was done manually, and we look what the machine just did, and then we can compare. And having the two, we know exactly how we rank, right? And to your question. To your question, we are developing it. It's part of the development. And when we reach accuracy, I mean, to a percentage that is equivalent to a human or what has been done, and I think the machine can even do better, in my opinion. But for now, we train it against the human. Once we make better than the human, then we're ready and we're confident that the model is fine. It's being developed at the moment, as we speak. Yeah. Thank you very much.
So Mathilde is actually taking part in the speed networking session next. So if you have any more questions, feel free to